What we're going to do to analyze and graph this is we're going to take this equation and we're going to just look at some things. I'm going to pick out the E value, which I know is 2. Remember from our equations earlier, E is this number right in front of the sine or the cosine. So in this case, that's a 2. Then I can find D. I know that's 3. This number right here, this 6, that's E times D. So if I know E, all I have to do is take that and divide it by 2. That gets me 3. Because E is 2, I know this is a hyperbola. It's greater than 1. And I can know that the directrix is y equals 3. That comes from earlier. It's a y equals because it's a sine. It's positive because it's a plus. And it's 3 because that's what D is. I can find the transverse axis by using the equation earlier. 2 times E times D over E squared minus 1. I go through, I simplify that, that's 12 over 3, or 4. I can then find the conjugate axis. And the conjugate axis is really the same equation here, except with the square root in the bottom. So it's 12 over the square root of 3. If I rationalize that out, that becomes 4 square root 3, or approximately 6.9. These things I can find pretty quickly. Now what I'm going to do, I'm going to put some stuff here onto my graph. So I'll go ahead. I know that my focus is at the pole. It's always at the pole for what we're doing. So that's a focus. I know there's a directrix at y equals 3. Come right up here. Put in a line. That's a directrix. And somewhere in between the focus and the directrix is the vertex. Now, I know this has a distance of 3. And I know that E, that's a ratio. That's the ratio of the hyperbola. What I'm going to do specifically is the vertex to the focus over the vertex to the directrix. And I know that's a 2 to 1. So the easiest way to do this, and the way that, well, maybe not the easiest way, but the way that will always work, is I'm going to do 2n plus 1n. So that'll give me my 2 parts, 2 and a 1. And that has to add up to 3. That's the distance between the focus and the directrix. Solve that for n. N equals 1. Plug that in. So 2 times 1 is 2. So 1 part has to be 2. 1 times 1 is 1. 1 part has to be 1. The 2 part, this has to be vertex to focus. This has to be vertex to directrix. So that tells me from the focus to the vertex has to be a 2. So my vertex goes right there. Now everything I've got, I can just count. Transverse axis, that's vertex to vertex, is 4. So if I know where this first vertex is, I can count 1, 2, 3, 4. There's my second vertex. My second directrix is 1 away from that. It's right here. That's my second directrix. My second focus is 2 away from the vertex. It's right there. The center is right here in the middle. That's the center. Now the conjugate axis, this gives me my side-to-side stuff, not vertex to vertex, but in this perpendicular way. Now, it's a little bit hard to count on a circle graph, but I'm going to do my best. And I'm not going to go 6.9 to the right and 6.9 to the left. I'm only going to go half of that, which is about 3.5. So 1, 2, 3.5. 1, 2, 3, and about a half. So that's about right there. And that gets me that little box that we did with hyperbolas before. I can put that little box in, and then I can put in, and I'm just going to use solid lines. I know we don't normally, but I am just going to use solid lines, and put in an asymptote and the other asymptote. So these green lines, those are asymptotes. So I use the conjugate axis to get how wide those should go. And then I can just sketch in my hyperbola. It follows right along there. Goes through the vertex, and I get that hyperbola that looks like that.